Welcome to Daily Papers, the podcast where we break down the latest research into bite-sized conversations.
Today, we're talking about giving artificial intelligence a better memory. Imagine trying to read a huge novel like Moby Dick, but you can only remember the last page you read. You'd probably forget who Captain Ahab is, what a whale is, everything.
You'd lose the plot completely. Well, that's a very real problem for the large language models, or LLMs, that power tools like ChatGPT. They have a limited attention span, and a new paper proposes a surprisingly elegant solution.
Let's start with the problem itself. LLMs have what's called a context window. You can think of it as their short-term memory. It can be pretty big, but it's always a fixed size.
Right, so if you feed it a 500-page report, but its context window is only 100 pages, it literally can't see the beginning of the report while it's reading the end. It's like a goldfish swimming across a very long pond.
A common trick to get around this is something called recurrent memory. The idea is to have the AI read the long document in chunks. After each chunk, it updates a little summary, a fixed-size memory block, to keep track of the important stuff.
It's like reading that 500-page report one chapter at a time. After Chapter 1, you jot down some notes on a single sticky note. After Chapter 2, you erase the sticky note and rewrite it with a combined summary of Chapters 1 and 2. You keep doing this all the way to the end.
But there's a huge flaw in that plan. The sticky note is still a fixed small size. Every time you update it, you risk erasing something important you wrote down earlier. By the time you get to the final chapter, you might have accidentally erased the most critical detail from the very beginning.
And that's exactly what happens to these AIs. Their performance gets worse and worse as the document gets longer because they keep overwriting their own memory.
This is where the researchers behind today's paper, multi-head recurrent memory agents, got really clever. They decided to diagnose exactly why this forgetting happens. They broke the process down into two distinct parts.
The first part is memory capture. This asks, does the AI even notice the important information in a new chunk and write it down on its sticky note in the first place?
And the paper shows that yes, the AI is actually pretty good at this. It sees the key fact, understands it's important, and jots it down. The capture part works.
But the second part is memory retention. Can the AI keep that important fact on its sticky note all the way to the end? And that's where everything falls apart. The information is captured successfully, but then a few updates later, it gets overwritten by newer information.
That's the key insight. The problem isn't that the AI is a bad note-taker. The problem is that its notebook consists of a single erasable page. The paper identifies this retention failure as the main reason these systems fail on long documents.
And the solution they propose is, in hindsight, beautifully simple. If having only one sticky note is the problem, why not give the AI a bunch of them?
Exactly. This is the multi-head part of the paper's title. Instead of one single monolithic memory block, they partition the memory into several independent blocks, which they call heads. Imagine having, say, 4 or 8 sticky notes laid out in front of you instead of just one.
So when the AI reads a new chunk of the document, it doesn't try to update its entire memory at once. It uses a smart two-step process: select, then update.
First, it selects just one of its sticky notes to write on. The crucial part is that all the other notes are left completely untouched. They are architecturally protected from being erased.
Then it performs the update, writing the new summary onto that single chosen note. For the next chunk of the document, it can select a different sticky note to update, again leaving the others safe.
This simple change is a game changer. It shifts the burden of remembering from the AI's behavior to the system's architecture. The AI no longer has to try not to forget. The system is designed to prevent it.
And they even came up with a really simple, efficient rule for which sticky note to pick. They call their lightweight version MHMLRU, where LRU stands for least recently updated.
It's as simple as it sounds. The system just picks the sticky note that it hasn't written on for the longest time. This ensures all the notes get used evenly and prevents the AI from just overwriting the same memory slot over and over.
So does giving the AI more sticky notes actually work?
Oh, it works incredibly well. The researchers tested it on some really challenging tasks with enormous documents. We're talking nearly 1 million tokens, which is hundreds of thousands of words.
Wow, and what happened?
The old method, the one with a single memory block, forgot most of what it read. Its memory retention rate plummeted to below 30%. It was basically guessing by the end.
And the new multi-head method?
It achieved a memory retention rate of nearly 74%. That is a colossal improvement. And because it remembered so much more, its accuracy in answering questions about the document was dramatically higher. Its performance stayed strong and stable even at extreme lengths, while the old methods just fell off a cliff.
What's so powerful about this is that they didn't have to retrain the underlying LLM at all, which is incredibly expensive and time-consuming. They just changed the structure of its memory system.
Exactly. It's like giving a student a proper notebook instead of a tiny erasable whiteboard. You haven't made the student inherently smarter, but you've given them a much better tool for the job, allowing them to perform at their full potential.
That's all for today's Daily Papers. Join us next time as we explore more research that's shaping our world.